We're going to start with section 3, and we're doing series now. And basically the difference between a sequence and a series is now we are doing the summation, the sigma notation that we introduced to you a few lessons ago. So just a reminder that if I ask you to add all of those values together, the sequence turns into a series, and we write it this way. So we have practiced doing the first one, where, as a reminder, this is just notation to say that 1 is replacing the I, so we're doing a sub 1 plus, because of the sigma notation, a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Now, the only other information that you're given is that a sub 1 is negative 2, so I'll write it right here. And then right here we have the recursive defined. It's defined recursively as the next term is 5 more than the first term. Well, that means that the second term is 3 because that's 5 more than negative 2. And the next term would be 8 because that's 5 more than 3. Plus 13, 1, 2, 3, 4. So the fifth term must be 18. Now, as far as coming up with an answer, I'm fine if you just use a calculator, but there is a shortcut that you're actually going to look at with the next problem, which is the rainbow addition. But if you start adding things together, you get 1 plus 8 would be 9, plus 13 would be 22, plus 18 would give me 40, if my addition is correct. So as we move on to the next problem, there's something called, and this isn't a full formal math term, but there's definitely a pattern that happens when you have an arithmetic sequence. And what that pattern is, okay, so we have this, they already gave us the recursive definition, which we start with 3, and then we're adding 2 to each term, so 5, 7, 9, 11, 13, 15, 17. So they already gave us that information. So like this would be probably set up as a problem such that you would say, and it doesn't have to be I want to point out that you can have any letter you want here. Sometimes it would be J, and then you could see 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of these. And you could actually come up with your own equation here. And maybe your equation would be like 2J plus 1, you know, if you actually wanted to come up with an equation to write out there. But that's a little advanced for what we're doing right now. What their question is, and they walk you through how to come up with a shortcut, is to realize that if you add the first term with the last term, 3 plus 17 gives you 20. And that's true for all of these pairs. And why is it true? Just think of it this way. Well, if I add 2 to this number and I take away 2 from this number, the sum is still 20. So the top rainbow, so to speak, is 20. 5 plus 15 is still 20. And that's true of any arithmetic sequence because you're adding the same number throughout. So the middle would be 20, and the middle 2 would be 20 as well. So why does it make sense? This is up to you how you want to answer this, and I would just say like you add the same difference. I know that's an oxymoron. So I'll just put the D value for difference that you subtract later on. Because in this specific problem, we're adding 2 here, but we're subtracting 2 backwards. So as we look at this, we can quickly say, okay, well, each pair adds up to be 20. We have 4 pairs in this problem. Now, let's summarize that. Why do we have 4 pairs? Well, we have a total of 8 numbers, as I mentioned from the get-go, from 1 to 8. So that comes from the n value divided by 2. I hope that makes sense because pairs happen in 2s. So what would the total sum be? It would be the multiplication is 20 times 4. So this sum should be 80. And you could check that if you went to a calculator and you started typing in 3 plus 5 plus 7 plus 9. I'm going to stop there. You can see that the sum would be 80. So how can we come up with a pattern for this? So clearly we took 4 and we multiplied it. Now, where did the 4 come from? It was from the number of terms divided by 2. Now, as far as how did I figure out where 20 came from, because you won't always know what all of these numbers are, but you can definitely figure out what the first term is. It's usually given to you in the problem, and then you can add to it the very last term. So all you need to know is the first term, the last term, and how many terms occur, and you have the equation for, sometimes we use S for sum, the sum of this. And again, this is your formula for an arithmetic series. And series just means we're adding all those together. So maybe before moving on, and you can hit pause on the video and rewatch any of this. I'm just going to go back up to the top and see if that pattern still worked. Now, you might be sitting there and saying, well, what about the fact that we had an odd number of terms? I would say you're absolutely correct, but the formula still works because there's 5 terms divided by 2, and then add together the first term with the last term. So we end up with 5 halves times 16. Well, 5 times 16 is 80, and then divided by 2 gives you the correct answer of 40. So it actually doesn't matter if you have an odd number of terms. The formula still works. It's kind of neat. Now, if you missed any of that, it's already on your piece of paper. Hopefully this is readable for you, where you have n divided by 2 times the quantity of the first term plus the last term. And just like when I talked about the series notation, you can replace these with different values. Yeah, let's stick with that. So let's stick with this formula. This formula makes the most sense, though. So when I ask you to find the sum of the first 100 natural numbers, just make sure you're familiar with what natural numbers are. So those are numbers that start with 1, 2, 3. So what are the first 100 of them? Well, it goes up to 100. So if I followed through that pattern, there's n is equal to 100 divided by 2. The first number is 1, and then the last term is 100. So without going to a calculator and hitting 1 plus 2 plus 3 all the way to 100, you can use this formula. I would anticipate you know that 100 divided by 2 is 50, and then 1 plus 100 would be 101. So 5,050 is your correct answer. So there's 4 different exercises here to play around with, because all we need to know in this problem is what's the n, what's the first term, and what's the last term. Well, in this problem, they're actually kind of nice that they tell you that there's 16 terms, so we know n is 16. But they didn't have to tell us this because, let me switch colors real quick, we could use this formula with the common difference to figure out how many total terms there are. For instance, and I'll switch to blue now, is we know that the nth term is 50 based off of this problem. We know the first term is negative 10, and we know it's 16 because the problem said, but let's say we didn't know it was n was 16. We know that the common difference here is 4. We're adding 4 each time. So if I went through and I solved for this problem, 60 is equal to, I just add 10 over. I would actually divide the 4 over next. So I would get 15 is equal to n minus 1. We could actually figure out, using algebra and using the formula we learned in the previous lesson, that n should be 16. So now, let's switch back to pink, or this pinkish color. We can use this formula where we have 16 divided by 2, number of terms divided by 2, the first term plus the last term. And for our purposes right now, you're allowed to use a calculator. although I think you could do this in your head, that 8 times 4 is 32, so this sum must be 320. So why did I bring up this green equation is because, well, I guess in this problem they do tell you that there are 20 terms. So we know that n is 20. We know the first term is negative 8, but we don't know what the last term is. So that's why I'm going to use that green equation. Maybe I'll even write this in green, where we don't know what a sub n is, but we know the first term is negative 8. We know there's 20 terms. And we know that the common difference is 6. So if I use my calculator, I'll even switch over to a calculator because I don't feel like doing, well, I guess I could do that in my head, but 6 times 20 is 120 minus 6 if I distribute, so that'd be 114 minus 8 would be 106. Just to double check because I don't always trust my math. Yeah, 106. So now let's switch back to pink and actually do the summation formula, which is n. I thought I switched colors again. N divided by 2 times the first term plus the last term. So this is kind of nice because we're going to look at 98 times 10, if I'm doing my math right, to get 980. So hopefully you've written down that green equation because I'm going to need it again. This time they give you the last term, but they don't give you the first term. So we can't use that first term in the problem. Well, we do know that n is 12 in the problem, though, because it tells us that the a sub 12 is the last term. So if I went back to that formula and I did negative 29, I don't know the first term. I do know that n is 12, as I mentioned, and they tell us that that common difference is negative 3. That's a multiplication. So as I'm doing that, I see that I have 11 times negative 3, so that's negative 33. That when I add 33 to the other side, now I know that the first term would be 4. And I can switch colors. I can go back to the formula now, where it's n divided by 2, the first term, plus the last term. And yeah, I've told you before, I don't always trust my math arithmetic skills. I think you could do that in your head, though, probably. Negative 150. And then there's one more, and as I mentioned before, they don't tell you what the n is, but you can tell that the common difference is 3 in this arithmetic sequence. So we know that the last term is 77, the first term is 5, but we don't know what the common difference is. Or sorry, we don't know how many terms there are. So subtract 5 over, we're looking at 72 equals n minus 1 times 3. I would divide the 3 over next. So 72 divided by 3 gives me 24. So if I add 1 to 24, I'm going to get n is 25. So we have 25 divided by 2, and then 5 plus 77, the first term plus the last term. And when you use a calculator, you'll get 1025. Okay. The math does get kind of complicated, so I'm okay doing that. So in exercise 5, really the same type of problem. This individual puts in $100 per month into an account, and he keeps depositing $10 per month each month, and how much will be in the account after 10 years. Just think about if we're doing 10 years and there's 12 months per year, that really there's 120 payments. So that's your n value. Your first term would be 100, because I'm guessing we're starting with 100, and then your 120th term, you would have to use a formula. Now I'm running out of time and I don't want to make a second video, so I'm going to jump to the answer key here. Is use the formula to figure out that the last term would be 1290. So if we did this problem, they would have $83,000 saved up and you should be ready for your homework now.